Hi! I was just using my binoculars to look for birds. Oh, there's one. Oh, hummingbird. Have you ever looked through binoculars before? I'll bet you have without even knowing it. Hey, today, let's talk about eyeballs. Let's start with the anatomy of the eye. The outside of your eyeball is covered by a very important lens called the cornea. The cornea is the only part of the human body that has no blood flow. It's completely clear, and that's what makes your eyes look glassy. The cornea focuses most of the light that comes into your eyes and is a protective window for the other parts of your eye. But because it's clear, it's not the first thing you notice about somebody's eyes.
The first thing you notice about somebody's eyes is what color they are.
The colored ring in your eye is called the iris. The iris can be blue or it can be green, but most people in the world have brown irises.
Usually, you have the same color eyes as your parents. This is because eye color is what's called a genetic trait.
That's why my son Jake has the same color eyes I do.
The iris actually doesn't just look pretty and tell us about our genetics. It does a very important job.
The iris surrounds a black spot in the middle of your eye. This is called your pupil. The pupil seems to get bigger and smaller depending on how much light is coming in through your eye. But that's actually a tiny muscle in the iris protecting the pupil from too much light. After light passes through the pupil, it hits the lens of the eye. The lens is what helps our eye focus, kind of like the lens in this magnifying glass.
Your eyes focus in milliseconds. You can't even tell that they're focusing. Put your hands over your eyes. Now move them. You can see in front of you without even thinking about it. Your eyes focus so quickly on whatever's right ahead of you.
Now you try it. After the lens focuses the light that comes through the pupil, it projects it onto the retina, which is a thin layer at the back of your eyeball. The retina surrounds the optic nerve, which sends information from the eye back to your brain. The optic nerves travel all the way through your brain, from each eye to the very back where the visual cortex is on the brain. That's where the brain turns the information that came through your eyes into images. It's actually your brain that sees, not your eyes. Here, we'll do this as our iris, and we'll use this as our lens. And here's our retina. So what goes in between all that? The inside of the eyeball is filled with a clear gel called the vitreous humor. That's what holds everything in place. Our eyes do most of the work to take care of themselves without even being told to. The eyelid, lashes, and brow keep particles like dust out of our eyes. And our eyes always produce tears because they help keep the eye from getting too dry and even have antibodies.
Even though our eyes do all that to take care of themselves, there are still some things that we can do to protect our eyes, like wearing sunglasses.
The sun creates a very powerful type of energy called ultraviolet radiation that can be very harmful to your eyes. Ultraviolet radiation is also what causes you to get a sunburn. When a person has no vision, that's known as blindness. You might have seen someone before with a seeing eye dog. These animals are very highly trained, and they act as a blind person's eyes. They help them find their way around. It's very important you don't try to pet one because whenever you see them, they are hard at work.
Being blind doesn't have anything to do with how smart you are, how funny you are, how capable you are. Actually, blind people are incredibly smart because they learn about the world without using their eyes. They even learn to read using their fingers.
Have you ever noticed little bumps on an elevator button or a doorway? That is Braille, a special kind of writing that blind people learn to read with their fingers. Different animals see the world in very different ways. When it comes to predators or animals that are hunters, and prey, animals that are hunted, there's a very big difference in the way our eyes work.
Prey animals need eyes facing outward so they can see around themselves, while predators need eyes facing forward so we can see how far something is and we can see in 3D. Did you know that I have a zebra painting? Zebra painting. Humans and other animals with forward-facing eyes have what's called binocular vision.
Told you you'd seen through binoculars before.
That means we can see very well, but only right in front of us. We can't see all the way around the side like some animals that are prey animals can. But to see even just right in front of us, each of our eyeballs sees things a little bit differently and sends a slightly different picture to our brain. And then our brain works it all out and makes it look like what we're looking at. This is something you can try to see how each of your eyes sees things a little differently. I'm going to look at my zebra and I'm going to put my finger right at his nose. You can look at anything around your room. Something on the wall across from you is a good thing to choose. So I'm going to put my finger right on his nose and I'm going to cover one of my eyes with the other hand. Yep, my finger's right on his nose. Now I'm going to take that hand without moving my finger and put it over my other eye. Oh, wait! My finger's not touching his nose anymore. On his nose, off his nose. That's because each of my eyes is seeing a little different picture. Just like if you stand here, things look a little different than if you stand here.
Now you give it a try. Did you know we all have a place on our eye that doesn't see anything? Where the optic nerve attaches to your retina, there are no light receptor cells, so nothing gets sent back to the brain. And there's one little place that's a blind spot that you can't even feel. Now you're going to need your bookmark with the eyeball and the heart and the word science on it. You're going to look at this side of the bookmark. Hold this up in front of your face just like this.
Now that you have your bookmark, we're going to do a little experiment to see where your blind spot is. I want you to take your right hand, that's this hand, and put it over your eye. And hold your bookmark out in front of your face. Now I want you to look at the plus sign with your left eye, with your other eye. And I want you to pull this slowly towards your face. Keep your eye right on that plus sign. Oh, right there is my blind spot. The circle totally disappears. It's like it's not even there. If I bring it a little closer, it reappears. If I pull it back out, keeping my eye on that plus sign, right there, it's just gone. That's the blind spot in my eye. You can try it on the other side too. Cover your eye with your left hand and with your right eye, stare at the circle. Pull it to you. Oh, right there, the plus sign completely disappears off the card. It's like magic.
Now you give it a try. Binocular vision is helpful in many ways, not just in hunting. Imagine trying to catch or kick a soccer ball if you couldn't see right in front of you. Yeah, that wouldn't work. That's why there will never be pigeon soccer. Because this tiger has binocular vision and both of his eyes are looking at the same thing, he can see past the grass and keep his eyes on his prey, whereas an animal with monocular vision would probably just see the grass. That's why animals like rabbits pull their heads up out of the grass to have a look at you if they see you coming. Having binocular vision allows us to see through things, kind of like X-ray vision.
Do you want to test your X-ray vision? Okay, hold your finger up right in front of your face and look at your finger. Now look at what's behind your finger without moving your finger. Look at that. You can see right behind the finger without even moving it. Now look at your finger again. Now look at what's right behind your finger. Your finger disappears.
Now you try it. Now let's talk about depth perception. Gather up some things from your supplies. Pause your device and come back when you have everything ready.
Because we have two eyes looking at almost the same exact thing, our field of vision overlaps, and this gives us the ability to see how far away something is. This is called depth perception. I'm going to show you what it feels like if you only have one eye to see from. So we have our supplies here that you've gathered. We have our pencil, and I want you to take your pen, take the cap off, and very carefully put it over here. And you're going to set the cap up and balance it just like that. Your glue stick is going to be balanced like this. Your scissors, your glue, your squash. If you have a squash, I guess you can use it, but it's really not necessary. So I want you to take one finger and touch each item. Now, cover one of your eyes with a hand. Take that same finger and touch everything again. It's a little harder to tell where everything is, isn't it? Because I'm only using one of my eyes, I can't really tell how far away things are from me. It messes up my depth perception. You can try it with the other hand too. Maybe put your finger inside the scissors, the holes there. Pin, the glue, the pencil. Now try again with the other eye. Cover your eye. Touch the squash. The top of the glue. Wow, that's even harder with this eye. Inside the scissors. The cap. Feels funny, doesn't it? Oh, don't forget. Cap back on pen. Oh, wow. Close one eye and try to do that. What? Can't even do it. Oh, that's really hard. I think that's a 2-eye job. Have fun.
Go ahead and pause your device while you give this a try. Prey animals don't really need great depth perception because they just need to know to run if they see something coming. That's why monocular vision, where they can see more of what's happening around them, is useful. And it's why they turn their heads to look at you. Have you ever noticed that about a chicken or a pigeon? When you get close to them, they turn their heads and look at you with just one eye. That's because their brain uses pictures from each eye separately. Now it's time for a visit to the field of vision. A lone wolf, hunting for a snack, sees a little squirrel in a field. The wolf, with his small field of vision and his binocular eyesight, is able to focus his X-ray vision on the squirrel, and he's able to see just how far away the squirrel is. But the squirrel, with his monocular vision, is able to see the wolf in his large field of vision. Will he escape in time?
So when the squirrel sees the wolf coming, oh, nerd, oh. A not surprising violation. Nerd, I know that squirrels don't breathe fire. That was just pretend. It was a joke. No, of course squirrels don't breathe fire. They're not giant and metallic either. No, the violation is that squirrels actually have binocular vision. But they're prey animals. Their eyes are on the sides of their head, like rabbits. I know they're crafty little creatures.
Squirrels have an amazing field of vision. They can see all around themselves, and it overlaps in front like ours. Otherwise, they couldn't go bounding through trees. They would have no depth perception. They can even see what's above them.
Squirrels. I did not know that. Thank you, nerd, for making me a little smarter today. Yeah. Okay. Your field of vision includes more than what's just right in front of you. It also includes your periphery. That's this part out here. So you can check your field of vision by putting your arms in front of you and staring straight ahead. You can see the arms still. Oh, now I can't see my arms anymore. Oh, now I can see them. Now I can't. So that's the end of my field of vision, outside of my periphery.
Your turn. Have you ever noticed an animal's eyes glowing in the dark? That's because the retinas inside their eyes are much more sensitive than ours, and behind their retina is a reflective layer, sort of like a mirror, called the tapetum, that makes them able to see better in the dark. Our eyes might glow red in the flash of a camera because we don't have a tapetum to reflect that light. Oscar, I knew you were half human. Vision sciences include many different specialists, from neuroscientists who study the brain to biologists who study the vision of specific animals. Even computer scientists use the study of vision in creating AI. Make sure you're taking care of those binoculars. See you next time.